we'll be talking about in physics video games and how they meld together and how physics is used inside video games. They're very much an integral part of video games. They make what 3D animation seem realistic and animation in general. If you don't have a basic knowledge of physics and how things move in real life, then you're kind of going to fall out with your animation. But physics engines, there are a few types. Most video games, let's say like Halo 3 or Halo Reach, I'm sorry, tell you which engine, which this one is the Havoc engine. And that is an engine made by a company that just deals with physics. They're closed source, limited, free distribution, as they're called, and there's a few of them. There's a lot of different physics engines. Some companies take it in their own to make their own software. And that software basically breaks down each and every movement and say a character gets hit across the screen, how far they're going to go, and everything. On top of that, there's another type of physics engine which isn't really talked about as a physics engine. It's a collision engine, which tells exactly when two items bump into each other. It detects when that hits, and then the physics engine takes into part how much farther back it should be, what deflection rate, everything in that. And that's what the main physics engine uses. So, some of these physics engines, like Havoc, they're ran in the background. You don't even notice them in your game because they're so well melded together with the graphic engine, working hand in hand to give you a seamless, realistic physics. Like if somebody falls, if you shoot a piece off a building, how that piece is going to fall and collapse and break down into pieces, that's all ran by the physics engine. There are particle engines, which is another type of physics engine, dealing with water and how its movement is or how gases move. Like say you're playing Splinter Cell and you throw a smoke bomb, how that smoke comes up and rises and just how it looks. That's another physics engine. There are many kinds of physics engines. The major ones are Havoc, Physics, Vortex. There's more than I can name at this point in time. There's just an outrageously amount of them. And then some companies make their own physics engines, and they're in their graphics engine. And hand in hand, you need your own dedicated GPU, and it actually takes a small part of that GPU and uses it just for physics, just to calculate every little thing of that physics. So, because without physics and animation, you can't have realistic animation. It gives you that realistic motion and everything. Because the mind's eye sees when something's off. You know, you can tell when something's off. That's why they're extremely important to have well-rounded physics. And I think that's why one of the reasons that it's taught to us. So we at least have a concept of physics. And like let's go for 2D animation. If you look at some of the animations that don't obey the laws of physics, most of us have already taken 2D animation, and you do the basic squash and stretch, and that's all physics. How much energy is dissipated into the ball and then rebounded back up, and how high it goes. You can tell when something's off, and it kind of bounces in that same area. Like let's say you drop the ball, it hits here and raises back up. It should go at least halfway. That's common knowledge. I did it with a ball just to make sure it was doing it right. This is why physics in video games is so needed. It's a main point of video games. I hope you like my talk on physics and how they would help video games and how they help video games and just how they need that dedicated engine. Thank you.